In this movie, we want to show you how to create a Bloom Unit Aimable Luminaire that can be used in any SketchUp Bloom Unit scene. The first thing we need to do is obtain or create a suitable 3D geometry model of our chosen luminaire. You can build your own 3D luminaire model using the tools available inside SketchUp, but a much easier method is to find a suitable 3D model from the large number of freely available online libraries of manufacturers' lighting product. These come in various file formats that, in most cases, can be readily imported into SketchUp, providing us with ready-made and accurate 3D geometry for our new Bloom Unit Luminaire. So in our example here, we start by importing a 3ds file format model of a floodlight unit. This is one that we downloaded from a manufacturer's website. Once this model has been imported into our scene, we run cleanup. This quickly removes any unwanted surfaces or hidden elements, providing us with a more efficient and cleaner version of our floodlight model geometry. Next, we must rotate our luminaire model so that it exactly faces the -green axis direction. Then we need to repeatedly explode our model until the geometry only comprises of its primary surfaces. We do this to ensure that our model contains no sub-objects or inherent attributes that might interfere with the luminaire setup process. Next, we use SketchUp's tape measure tool to measure the width of the front face of our luminaire. This is to check that our imported model is at the correct size and scale. This is a very important step, because most imported models will be at the wrong size, and if we do not get this right at this point, then we will not be able to correct it later on, and we will be forced to restart the whole process again. Our measurements show that the front face here is about 540mm. From our manufacturer's datasheet, we know that this dimension should be 250mm. Fortunately, SketchUp has a great method for allowing us to quickly adjust the size of our model. We simply enter the correct dimension of 250mm into the measurements box in the bottom right hand corner of our screen. Then a dialog box will appear asking us if we want the entire model resized based on this new dimension. Click on the Yes button to correctly resize our model. Now we move the camera to a close front view of the luminaire model. For an aimable luminaire, we need to break our model up into two primary component parts. The first part is the base component, which is the mounting hardware section that will attach to any selected mounting surface and pivot around the component insert point. So, to set up our base component, we need to firstly select and hide any part of the model that will not be part of this base section. Then we move the camera to view the mounting bracket from the underside to help us more easily set the mounting insert and azimuth rotation point. We now select all the visible surfaces and create a new SketchUp component which we will call FLD3011 base. Next, we select Any for the Glue To option to make sure that this mounting bracket will correctly snap onto any surface in our SketchUp scenes. Then we set the component axis to match the insert point for whenever we place our new luminaire into any scene. This will also set the azimuth pivot point for whenever we re-aim this luminaire. Here we set this axis point at the centre of the underside of the mounting bracket. After this, we ensure that the Replace Selection with Component option is checked. Then click the Create button. Next, we unhide all of the luminaire parts and then hide the new base component we have just created. Now, we select all of the remaining parts which will form our tilt-able head component. With all these surfaces selected, we use the context menu again to open up the Create Component dialog. Here, we start by renaming the definition to FLD3011 head. We leave the Glue To option as none and then click the Set Component Axes button. This step is another very important part of the creation of our aimable luminaire, as the red axis must precisely match the hinge line for the tilting function of our new floodlight. To do this, we need to reposition the axis point to line up with the centre of the rotation boss on the side of the floodlight housing, as you can see here. The positive red axis line must be oriented so that it precisely aligns with what will be the tilt hinge line or axis of our head component. Again, we finish by clicking the Create button. The third and final object that we need for our new floodlight is the light source component, complete with the correct photometric definition. Before we start this part of the process, we need to measure the width and height of the luminous aperture of the floodlight model. Using the tape measure tool again, we measure 200mm for the width and 230mm for the height. Next, using Bloom Unit's Luminaire Manager, we add a new custom luminaire and change the name to FLD3011 Web. Then we use the Browse button to navigate to the location of where we have saved the IES file for our new floodlight and load this file. Next, we select Rectangle for the area light type, and using our earlier measurements, we enter 200mm for the width and 230mm for the height. Then we click the Place button to bring this new photometric web component into our scene file. Now we rotate and move this component to precisely match the correct position and orientation of the luminous aperture of our floodlight model. So here we've created and assembled the three components needed for our new aimable luminaire. This comprises of the base, the head, and the web, or photometry. There are two more steps to go before the process is complete. For the first of these steps, we open up the outliner dialog where we can see our three components listed. Remember to unhide the base component that we hid earlier. What we need to do now is reconfigure these three separate components as a single component. To do this, we click and drag the web component onto the head component, so that the web component is now a subcomponent of the head. Then, we drag this same head web component onto the base component, so that in turn the head web component becomes a subcomponent of the base, exactly as you can see us doing here. Now we have our complete aimable luminaire as a properly assembled single component. We now have one final step to complete this process, but before we do that, it is highly recommended that you save this version of your Luminaire file, which you may need for making further changes to or corrections later on. This is because in the final step, we will be running a Ruby script which will create some irreversible changes to the core of our SketchUp Luminaire file. So, after saving the current version, you should also save this file again, but with a different name to ensure that you do not accidentally overwrite your backup file with the Ruby script modified version. So here we save the file again, but with an added -x suffix to the file name. Now we need to open up the Ruby console. Then copy and paste the exact lines from this text file into the console area and press enter. To save you time, I've put a copy of these complete text lines in the description below. After the script has been run, and if there are no error messages, we have successfully and fully created a brand new Bloom Unit compliant aimable luminaire. All we need to do now is to save this assembled component version with a suitably descriptive file name in a central folder location for easy placement into any of your future SketchUp projects. So here we save our new luminaire with the file name FLD3011 20 watts LED flood. To prove that our new floodlight works correctly, we will now open up a SketchUp test room scene and use the import function to drag and drop our brand new luminaire into our scene. As we drag our luminaire across the various surfaces of our test room, you will note that because we selected the glue to any surface option for the base component, the luminaire correctly attaches itself to any of the walls, ceiling or floor surfaces. Now we start a Bloom Unit session. Once the Bloom Unit viewport opens up, we can see immediately that our new floodlight is illuminating the scene correctly. Then we re-aim the floodlight a couple of times at different points in the room to show that the aiming function is working correctly. Next, we import a second copy of this floodlight and place it on the opposite wall, and re-aim it across the room to demonstrate that each copy of this luminaire can be independently aimed. Now, for the final part of our movie, we would also like to show you a better way of both accessing and organising your library of custom luminaires. If we open up SketchUp's Components dialog, we can see an added folder in the Favourites list called Luminaires. Opening up this Luminaires folder, we can see a collection of separate subfolders, each for different lighting product manufacturers and group categories. Clicking on the Fagerholt subfolder, we see a collection of Fagerholt luminaire products and further subfolders. So we click on one of the Marathon MIDI luminaires and simply drag and place this product onto the ceiling of our scene. In the Bloom Unit viewport, we can observe the accurate interactive illumination combination within seconds. Utilising SketchUp's inbuilt component folder system, along with the ability to set discrete folders as favourites, provides some great advantages for managing your lighting product libraries, where not only can users set up custom files with luminaires being separately grouped by manufacturer, mounting type or application category, but it also provides a very flexible and fast method for selecting and placing your chosen luminaire into your scene. The other big advantage of custom luminaires over library luminaires is that with custom luminaires, users can interactively change photometric files, lumen output values and lamp source color temperatures. Furthermore, these luminaire files can be simply copied and then edited to quickly create new and additional luminaires within the same product family group. So, if you haven't tried Bloom Unit already, please visit our website at bloomunit.com for a free 14-day trial and experience for yourself the amazing capabilities of the next generation of lighting and interior design toolsets. It will be well worth the effort.